okay? To go back to yesterday in your packet. Trapezoid formula, 1/2 the height. We're going to take half the height. And what are we going to do after we take half the height? We're going to multiply that by the two bases. Remember, we called those B1 and B2 added together. Okay. And those are the parallel sides. The two bases are the sides that are parallel in the trapezoid. And for rhombus, we also had 1/2 in here. And this is all multiplication, all multiplication. We took 1/2, multiplied that by what we said was D1 and D2. A reminder, what was D again? Diagonal length. I'm not going to write that in again. Diagonal length. All multiplication. All multiplication. 2, not on your formula sheet. That's your responsibility. Okay, that's the 2 we do today, not on the formula sheet. We're going to start with the rhombus today. Remember when we did parallelogram and I said, hey, can you find the perimeter? And you were like, oh, this side's 15, so the other side's got to be 15. You used a property. There's a couple properties of a rhombus we got to review first before we can find the area. 3 in particular. 3 properties. There's more, but 3 in particular that we're going to need to help us find the area of any rhombus I give you. Anybody want to show off, spout out any? Rhombus. Cormac. All right, that's going to help us out. Diagonals are perpendicular in a rhombus. They form 90-degree angles. Yes, that's one property that's going to help us. Any other properties? All sides in a rhombus? Anybody? All sides congruent? That'll help us. And one more property about diagonals. Diagonals bisect each other. That will help us out. Again, I'm not saying these are the only properties of a rhombus. I'm saying those are the properties that will help us with the area of a rhombus. All right, go ahead. First example. I give you one diagonal 6. Area is 48. What about the other diagonal? What about the other diagonal? All right, get the formula down. Let's get the formula. 1/2. And I'll keep reminding you, it's all multiplication. Every year somehow I get a handful of students that put an addition sign in there. It's all multiplication. All right, one diagonal is a length of 6. So where can I plug the 6 into my area formula here? Bailey, where can I plug the 6 in? Okay, D1. Here we go. 1/2, 6. And then I have this other number over here, 48, which represents the area. So where's the 48 going into the formula? Cormac, where's it going? As A, area, right? Over here, 48. And we're looking for the other diagonal. You guys want to leave it D2? You can. You want to put an X there? And it's up to you. Solve it now. Go ahead, solve for the other diagonal. Maybe some of you are doing 1/2 of 6, giving you 3. And when you have it, let me know what the other diagonal length is there. Brendan, when you have it. 16. Reminder, first time this year, I'm going to be a stickler about because we introduced a different type of units for area. This is going to be what here? Should this be square feet or just feet? Feet or square feet? Okay, ready? Did we find the area? No, we didn't find the area. We just found the diagonal length. So it should be just the only time I square the units is when I do area. That's it. That is it. The only time the units get squared is when you find area. Speaking of finding area, here you go. Find the area of this rhombus. This is why we needed the properties. Based on one of the properties we went over, you should be able to find a diagonal length immediately. Based on one of those three properties we wrote down, you should be able to find another full diagonal length immediately. What's one diagonal we're going to know here real quick here, Lily?
The other diagonal is 40.
Good job. This piece here is 40. So what's one diagonal I can put in here, Lily?
Oh,
80. 80. Good. So we should all have 1/2 of 80. All right, now we're going to work on the other diagonal, which is using the other properties. First property somebody told me right away was, hey, diagonals are perpendicular. Yes, they are. Forms a right angle. That's what we're going to need here. All right, where are we going with this? To find the other diagonal length. Where are we going? Why did I put that right angle in there? Where are we going with this? Jonathan, where do you think we're going? Darn right we are. Good job. Where's the 40 and the 50 going? Into Pythagorean theorem. Where's the 40 and the 50 going? Nope. Stellan, where's the 40 and the 50 going?
40's going where A would be.
Yep. And what about the 50? Yep. That's the hypotenuse. Don't fall into the trap though here. When you have it, what's the other side of the right triangle there? When you solve for Pythagoras, Shara, when you have it, what's the other side? 30. I said don't fall in the trap. 30 doesn't go in the formula, does it? Got to double it. Diagonals bisect each other, so we should have 60 in there. All right, I do have 2,400. Square inches or just inches? You're finding area, so now you square the units when you find the area. All right, anything up on rhombus? Because we're done with rhombus. That's it for today for rhombus. Going on the rhombus. Just remember those three properties. That'll help you there. All right, trapezoid. A couple trapezoid examples. Let's get the formula down first. One half the height. Base 1 plus base 2, not, keep reminding you guys, not given to you. You can plug the 6 and 11 in. Where am I plugging the 6 and 11 in? Those are my bases. Yeah, 6 and 11 plus. We just got to work on the height. Looks like the height. Real quick, AD is a height, right? Vertice perpendicular to the opposite side. So AD is a height. I don't know if we're going to be able to find that. So I'm going to have you draw on the other height, which comes from B. So from vertice B, go ahead, draw your height in. Altitude. And yes, just like yesterday, look what's formed. 45, 45, 90. I have a little issue though here. This didn't happen yesterday, but it's happening now. I do not know any side lengths in that 45, 45, 90. Because 11, remember, belongs to DC, not anything in that triangle. I don't know any side length in that 45, 45, 90. Can somebody help me find a side length? Talk me through this. How can I find a side length in that 45, 45, 90 triangle? You ready to go, Brendan?
Oh, yeah. There's the 6 on top. So you take 6 from 11.
Okay, one. Yep, you're good. 6, opposite side, because this is probably a rectangle here with all the right angles. 6, yep. And then how do I get a side now?
You take the 6 from 11.
11 minus 6, that other piece has got to be 5. Good work. Oh. And conveniently, look where that 5's across from. 45. What's across from the other 45 then? What's the length? Jonathan, what's the length across from the other 45? Sorry. 5. Yep. They're always equal. And there's your height, everybody. 5. Good work, everyone. Good teamwork there. It does say leave your answer in simplest radical form, but we don't have any radicals here to worry about. And here's my other labeling rule. Was there any units on the diagram? Okay, so you don't have to put any yourself. I don't know in middle school that any of your teachers have. You have to put like a U there and then square it. That's ridiculous, by the way. Having a U for units, that's ridiculous. If there's no units, I don't expect any. Just leave it. All right, another trapezoid coming up. 7 and 11, those are your bases we can plug in. Just got to find the height. Just make sure you're adding the bases. Again, SR is a base. I'd rather find this height, or is a height. SR is a height, excuse me. I'd rather find this height, though, coming down from P, because that gives me a 30, 60, 90, which I'm familiar with. Can everyone use Brendan's technique to find the side of that 30, 60, 90? 7 across is 7. Let's see, 11 minus 7 is 4. Where's the 4 across from? 30, so that's the shorter leg, and I need the longer leg, which is the height. Longer leg is equal to shorter leg. What do you multiply it by? Radical 3. There you go. Good. So that means the side across from 60, the height's got to be 4 radical 3. The shorter leg times radical 3. Now you can leave it in simplest radical form. And when you have it, let me know. Shara, when you have that simplest radical form. Good job. 36, radical 3. Any units? Nope. So I wouldn't expect any on your area. Whew. Guys, good here because this next trapezoid one's a little more intense than these two here. Oh, look at that, Emilia. Guess we're dropping A's, no, not Amelia, Emilia. Little team pennant, that's cute. What's the area of her pennant? Everyone see the pennant, Team E, huh? They all got the names that start with E there, huh? Aaron, Amelia, and Elena. Who else could be joining this team? I'll start. Emily. Who else is going to do this? Come on. Eric. Yeah, hey, it doesn't have to be just ladies here, right? What else we got? Elizabeth. Everett. Nice. That's one we didn't have last period. Who's joining Team E here? Come on, we got a bunch here. Who? Edward. Ed. Yep. Can't forget about Ed. Enrique. Yeah. Now we're going. Yep. We're getting it. Emmanuel. Yeah. So as we do this problem here, just yell them out. All right. Just yell them out. And if anybody notices, it's the team with the edge. Oh, it starts with E. This problem's unbelievable. Yep. If anybody has any more, yell them out. Who should be on Team E here? 1/2 the height. Emma, come on. That's classic. Ella. Yep. I'm waiting for more.
Elizabeth.
Yeah, it's all right. It's been said, but it's okay. Thanks for the contribution. All right, going back to the pennant, there should be 2 out of these 3 values we can fill in. What's the 4? Whoa, whoa, whoa. What's the 4? That's the height, right? That's the, hey, I know some of you, we are going to use this height, but yeah, these are both heights that are the same. So 1/2, 4. And then how about the 10 inches? 10, everyone, that's a base. So what we need to find to finish this pennant off is what's the other base, which I will highlight in yellow right here. What is the length of that remaining base? All right, I'm going to highlight it in green. Remember I said, hey, we are going to use this height, which we already know is how long? 4 inches, right? That's 4. All right, I'm going to let you guys look at this now. Remember, I need to get to the yellow base right there, the yellow base. I need a plan here on how I'm going to get to that yellow base. Any plan here? How I can get to that yellow base with all the values I have now? Cormac, what's good?
Cut the rectangle in half and 45
So I want to cut the rectangle in half. Like put a diagonal?
Yeah.
How are you going to know the other 2 angles are 45, 45? Why couldn't they be 30, 60?
Because it's a right angle. So it gets,
So wait, you're saying go like this?
yeah.
But how do you know those are?
Bisect the angle.
Okay, now you're just saying it's bisecting. How do you know though? Right? It could be 45, 45, 30, 60. It could be 10, 80. Any combination that gives me 90, right? All right, good. At least you threw it out there, had the guts to throw it out there. I respect that. Lily.
Did you do 10 minus 8.5?
If I knew this was 8.5, yeah. But I don't know that that's 8.5 though. Where are you getting the 10? Why subtract these here?
Because doesn't the 8.5 end?
This part here?
Yeah.
Not necessarily, no.
Oh, let's see.
Nope. They're not. I don't know if these 2 together add up to 10 or not. I don't know that. We're getting there, though. We're getting there. Any other suggestions? This triangle right here is what type of triangle? A right triangle. How many sides do you already know? 4 and 8.5, right? The 10 is not part of it. Remember, 10 is the whole base. You know 4 and 8.5. Can you find the third side? Using what? Pythagorean theorem, and then I can use that third side and subtract it from 10. All right, so that's our plan right there. A squared plus B squared equals C squared. Let's see, the 4 is going to go in for A. Where's the 8.5 going to go in for? C, yep. Ethan. Evan, yep. Enzo, yep. I've heard of that name. All right, so everyone should have that third side of the right triangle to be 7.5. After doing Pythag, I take 10, subtract 7.5. That other base will be 2.5. 2.5. And again, we get 2.5 from doing 10 minus 7.5. And the area of the pennant, 25. Anybody else for Team E? Before we end this, we're good? Okay, I think we got a good, decent amount of names for Team E. All right, last one. I know this is now a parallelogram. Okay. It's not a trapezoid, or it's not today's topic, but it was yesterday's. Find the area and perimeter. Let's start with the area, kids. Let's start with the area. Base times height on the formula sheet. What value up there can we already plug into that formula, and where are you going to plug it into? Shara, back to you. What number and where we plug it into? 12 for the base. Good work. So 12 times, all right, let's find the height. Something different's going to happen here. Everyone sees where the height is. We know that from yesterday. There's the height. Usually, we'd have a 30-60 or a 45-45 on our hands. Now we don't. This is why I had your calculator in degree mode at the beginning of class today. If it's not a 30-60-90, if it's not a 45-45-90, I need to use, as long as you can spell it, Pocahontas' brother, SOHCAHTOA, to find that height. I have to. I don't have a rule for something that's got 35 degrees. I can't go over this as slow as I did when I taught it to you. Everyone look at 35. Ready? 35. What is the 4 yards? What is the 4 yards? Is it opposite? Is it the hypotenuse or adjacent with the 35? That is opposite, right? And if you guys want to, if back in the day when I showed you this, we'd put a little O next to the 4 that says that's the opposite side. And what's the height of the parallelogram, the side we're looking for? That is adjacent, yes. So I have opposite and adjacent. Which one of the 3 ratios do I have enough info for? Not TOA, but tangent, right? All right, so tangent. Let's review how to write the equation to solve. Tan, abbreviate it, TAN. What's my angle I'm working with? Tan of 35 equals, now I write the ratio, opposite over adjacent. And that's why we label them. So 4 over H. How did we solve? I had you guys put this over 1 and cross them up, right? Cross multiply. That's how we used to solve these. So one side you have tangent of 35 times the height, H, equals, on the other side when you cross multiply, you got a 4 there. How do we get tan 35 by itself? Anybody remember how we got tangent, in this case, tangent, or H by itself here? H by itself, Stellan, remember what we did?
Divide by 4. Divide by tangent.
Tan 35, good. And you can do that all in your calculator now. And this we've said all year long, we don't round until the very end, right? So that long decimal that's staring you in your face right now, which is what, 5.712592027. We're not going to round it. We're going to plug it back in and multiply it by 12. Then you can look at the rounding directions up top. Look at the rounding directions. Nearest hundredth, 68. I'll give you that. I'll give you the 68 point hundredth, which is what? 2 numbers after the decimal. So you look at the third if you need to round or not. 68.5. Five, thank you. Yards squared. And then last thing, what's the perimeter? Okay, what is the perimeter up here? Well, we already know two sides are what? If we're going to find the perimeter, what do we already know with two sides? Let's see here. Shoom, going deep there, not here. There we go. Let's go. Alexi, what's two sides we already know?
12.
Yep. So 12 plus the opposite side, 12, because it's a parallelogram. All right. Now, what about these sides here? You guys could find that side two different ways. Two different ways. Anybody? Remember, you already know the height now. You already know the height, and you already had 4. How could I find this side now? I could use Pythag with my non-rounded answer over here, 5.7. Or, let's see, you have opposite side was 4, and now you're finding the hypotenuse. So opposite and hypotenuse, you guys could use sine now if you wanted to. Sine of 35 and set that up. Either way, I don't care. Go ahead. Use sine ratio or Pythag. If you are using Pythag, though, remember, you got to use the whole 5.712. And no matter how you guys did it, keep working. You should have 6.973787182. As that other side of the parallelogram. Really getting after it out there, huh? Add up all 4 sides of your parallelogram. I'm getting 37.95 yards. Oh, I just gave that away, but should I square the yards? Square the yards? Nope, only area. This is perimeter, so it's just plain yards. Keep your graph paper for tonight. You're going to have to graph again. If you do need extra, they're over there on the cabinets.